Morning, everybody. March 24th, 2014. This is a more challenging percent problem that might appear on a standardized test and has in fact appeared, similar type questions, on SATs, could be on ACT, the new PARCC test, the new Smart Balanced test, and other standardized assessments. And from my perspective, it's a question that can be introduced in middle school. Percent questions can begin as early as 6th grade, in my opinion. And you can check that in the Common Core curriculum. In this particular question, what perhaps makes it more challenging is that you have more than just a part and a whole, but rather you have a whole with parts, and then one of the parts becomes the new whole for other parts, which leads to the idea of a fraction of a fraction or a percent of a percent, and this can be done in a variety of ways. Let's get right down to it. 40% of the 9th graders play sports. Well, it should be plural there. So we'll call this the whole, A-W-H-O-L-E, and there it is, the whole. 30% of 9th graders who play sports, that's in blue here, are boys. So although there are many ways to organize the information, and we know that unless trained to do so over a long period of time, students do not generally organize the information in the problem like this, particularly under standardized test conditions when the clock is ticking. This is useful for me, so I'll share it. One branch comes down to the 9th graders who play sports. The other branch, which corresponds to 60% of the whole, is the non-sports students, and in fact we're not really interested in that group or that part, but I did it for the sake of completeness, and when you're doing the problem you may not have looked far enough ahead to see that you don't need it. Anyway, the students who play 9th grade sports break into two categories: the boys who play and the girls who play 9th grade sports. And eventually we get down to the number in the problem, which is 140, and that's the part we're starting from. So let me erase this little mark here. Okay, so let's begin. 140 represents 70% of S. So a straight algebraic approach would be like this. So 140 divided by 0.7 equals S, and S equals, I'll show this in case it's a non-calculator part of the test, so S equals 1400 over 7, 200. All right, we've climbed back up now. We now know that the blue box, this part, which is for the beginning of the problem, the whole, consists of 200 students. So we'll put 200 here. And now we repeat the process for the 200 students. We know represents 40% of the whole. So I'll write it up here. So 200 equals 40% of N, using N for the total number of students in the 9th grade. Again, divide both sides by 0.4. So N equals 2000 over 4, using good skills so that we don't have to rely on the calculator, and the final result is 500. Pretty straightforward, but we also know that there are so many other approaches. The first way you're introduced to an idea or a skill or a technique or an algorithm, whatever you want to call it, is the way you tend to retain. That's the method that'll stay with you the longest. So if you observe students in high school, many would still set up this calculation down here as a proportion. Not that there's anything wrong with that. 70 is to 100, part is to whole, as 140 is to S. Nothing wrong with this. Cross multiply, solve for S, reduce it, do whatever you need to do and obtain the result. The same thing could have been done down here. Since we're really dealing with a percent of a percent, 70% of 40%, the more advanced student may be able to do this in apparently one step. I say apparently because it is kind of combined into one. All right. So we know that the 140 students represent, those girls represent 70% of the blue region, the blue, which is 9th grade sports players, and they represent 40% of N, 40% of the entire 9th grade. So 140 equals 0.7 times 0.4 times N. So I'm skipping some steps here. N equals 140 over 0.28, the result of multiplying 0.7 times 0.4. Doing the division, let's say 14,000 over 28, we get 500, or just do it on the calculator. I'll write it down here, 500. And there's the final result. Let's go back over this again. We have a standard, more difficult percent word problem. These questions are not going to go away because if we read what David Coleman said from the College Board, we know they're going to be stressing ratio, proportion, and percents in application. This is the kind of question, I believe, which will persist on the new SAT. We also talked about how to approach it without a calculator. We used a tree diagram, although a matrix chart table, whatever you wish to call it, or a Singapore bar model could also be used to represent the parts and the wholes. We highlighted important information to identify which is the part and which is the whole in the problem, as well as in the tree diagram, and that enabled us to set up these equations fairly easily. There are so many ways to set this up, and finally I wish to say I'm well aware that there are many other ways students and professional educators would approach this, and the different pedagogy that the professional would bring to the class. This is just a suggested method to demonstrate the mathematical practices of the Common Core. Thank you.